Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some factoring, so let's get into it. So factoring, you have a few unique scenarios, and then you have the typical factoring problems that have three terms. So we're going to start with the unique scenarios with the greatest common factor. Regardless of what factoring problem you're dealing with, you want to always look for the greatest common factor first. So if you look here, they both can be divided by 3. And they both terms, the first and the second term, both have an x in them. So you have to ask yourself, how many x could they each relinquish? And they could each relinquish at least 3 because this has an x to the third. Okay? So we're going to factor out a 3 because they can both divide by 3. And we're going to factor out an x to the third because they both had at least an x to the third. All right? From here, we are going to recognize that this 3 divided by 3 becomes a 1. And then x to the fourth divided by x to the third ends up being x to the first. Okay? So from here, then we are going to also divide the 12 by 3, which gets us 4. And x to the third divided by x to the third gets us x to the 0 power. So we're just going to write x minus 4 there. Okay? Now, the next thing we have is a 12x to the fourth minus a 15x to the eighth. Well, here they both can't divide by 12, but they can both, again, divide by 3. Both 15 and 12 divides by 3. And then if we factor out an x to the fourth, because they both have at least an x to the fourth, you divide 12 by 3, you get 4. You take away an x to the fourth, you take away another x to the fourth, that goes away, canceling. And then if you divide 15 by 3, you get 5. Take away 4 x's from 8, you get x to the fourth. All right? Number 3, although you're not required to, it is recommended in other problems to maybe factor out the negative. It makes it easier. And they both have an x to the third. So I'm going to factor out a negative x to the third out. That would make this a positive x squared. You'd take 5, take away 3, and you have x squared. And then because negative 1 times 1 makes negative, that's why it's there. And then this would be plus 12, and then there'd be no x's. Okay, so that's the greatest common factor. The next thing we have to deal with is difference of perfect squares. So as long as you have a perfect square, if both terms, the first and the second term, are square rootable, and there is a minus in between, then you can do this trick. Okay, so you essentially take the square root of 25, and that would be 5, and we will end up with a positive 5 and a negative 5. All right? And it coincidentally multiplies to 25, negative 25, and adds to 0 because that middle term is 0. This next one, we have a mistake. It should be a 9x squared minus 50y squared. They both are, no mistake, excuse me. 8x squared minus 50y squared. I thought there was a mistake. No mistake. We divide both things by 2. Always look for your greatest common factor. When we do that, if we divide both things by 2, we get 4x squared minus 25y squared. Okay, so the dividing by 2, now look at the 4, look at the 25. Because they both are square rootable, and it's an x squared and a y squared, we can do exactly what we did before. Just don't forget the 2 in front. So we're going to have a 2x, because square root of 4 is 2, and a 2x, because square root of 4 is 2, and a 5y, and a 5y, because square root of 25 is still 5, and the square root of y squared is y. So we're going to have one positive, one negative. Doesn't matter which order you put them in, though. As long as you got a positive 5 and a negative 5, and then the 2 in front. Here, do not forget to divide by 2, or any greatest common factor. We divide by 2, you get x to the fourth minus 16. And then from here, even though we have an x to the fourth, 4 is still kind of a square rootable number. So as long as this is an even root, an even degree polynomial, and this is a square rootable number, then the perfect square will work. So the square root of 16 is 4. So we'd end up with x squared minus 4 and x squared plus 4. Okay? And x squared times x squared makes x to the fourth. And 4 times 4 makes 16, and 4 plus 4 makes 0. Now, this does keep going. X squared minus 4, 4 is square rootable, and x is still a perfect square type of thing. So we have x plus 2 and x minus 2 because it's the square root of 4. But the x squared plus 4, because it's positive, cannot do anything. So that is why it is still x squared plus 4, and I didn't do anything with that one. All right, now we get to the normal factoring problems. The normal factoring problems are going to be 3 terms, just like we have here, and they are going to be dealt with a little bit differently. So what we want to do, as long as there is no number in front or an a value of 1, see how here it's a 1 and here it's a, well, that's a 2, but we're going to factor out the 2. As long as that's the case, then you want to list out the things that multiply to 20. If we think of the things that multiply to 20, we have 1 and 20, and 2 and 10, and 4 and 5. Out of those, what we could call magic numbers or the factors of 20, which one of them, via adding or subtracting in some way, shape, or form, could add to 9? That would be the 4 and the 5. Okay? So once we get those two numbers, I like filling in my x's, and then I fill in my 4, I fill in my 5. You ask yourself, well, what do the 4 and the 5 have to be in order to add to negative 9? And that is, they would both have to be negative to add to negative 9, and this would be the factor version of the original answer. Okay, next one. It looks easier, but this is actually a very typical mixed question. I'm going to put in a negative 6 here, but you may notice that I'm not going to write 1 times negative 6. I'm just going to write 1 and 6. I'm just going to write 2 and 3. Now, those are the only factors of 6. Now, you may notice that 2 and 3 can add to negative 5 because 2 and plus 3 makes 5. And 6 minus 1 can also kind of make a 5. In this case, because it has to multiply to negative 6, one of the numbers has to be positive and the other one has to be negative. In order for one of them to be positive and the other one to be negative, in this case, it would be positive 1 and negative 6. I don't worry about the positive and negatives until I have to worry about the adding 2 part. Okay, so don't worry about the positive 1, negative 6, because then you have too many variations. You have negative 1, positive 6, negative 2, positive 3, negative 3, too much. Okay, so we got x minus 6 and x plus 1. There's our two factors. We're good to go. The third question, we have to factor out of 2. Always look for your factors first. If we factor out of 2, now we have x squared minus 7x minus 18. Okay? If you don't factor out the 2, it'll still work, but it won't work until we at least talk about how to deal with it if it is a number in front. So what multiplies to 18 but adds to 7? Well, we got 1 and 18, we got 2 and 9, and we got 3 and 6. The ones that will add or subtract in some way, shape, or form to 7 is the 2 and the 9. So don't forget the 2 that we had out front. We got an x. We got an x. We're going to throw the 2 here. We're going to throw the 9 there. Now we think which one has to be positive and negative to add to negative 7. The 9 would have to be negative, and the 2 would have to be positive because negative 9 and positive 2 add to negative 7. 2 times 9 is 18. These two add to the middle number. Here's our final answer. Let's move on to the ones that have a greater than 1. In order to do the problems like this, still always look for your greatest common factor. If you forget it, your answer will be a little funky and off. Okay, so make sure you're looking for the greatest common factor. Before you can just multiply, before you just write the 5 here, you have to multiply 5 times 9. So we get 9 times 5 to equal 45. That is the number that we want to figure out what things multiply to 45. Well, we have a 9 and a 5. We have a 1 and a 45. And we have a 3 and a 15, I believe. Okay, there might be another one, but I can stop there because I see that 3 and 15 still add to the 18. All right, so that's what we're going to write down. We're going to write an x, we're going to write a positive 15, and a positive 3. From here, we're not done because you may notice that 15 times 3 equals 45. It does not equal 5. Okay, so the final answer must do these two numbers multiply to 5, but this doesn't. So what you need to do here is we multiplied by the 9 at first. We need to divide by that 9 now. Okay, so you multiply in the beginning and then you divide at the very end. Sometimes it divides. Sometimes it simplifies. Okay, so in this case, both of them simplify. If both of them simplify, you need to be very careful that you couldn't divide by something in the beginning because normally that's a red flag. So here, nothing divides by nothing can divide 9, 15, and 5. 18 and 5. So we simplify. What can we divide both 15 and 9 by? Well, that would be a 3. So this would be, if you simplify it, it'd be a 5 over 3. And if you simplify 3 over 9, you get a 1 over 3. Okay? Now that they have been simplified, again, 5 over 3 times 1 over 3, that doesn't seem right. What you end up doing is, with your simplified answers, you put the 3 in front of the x and the 3 in front of the x. So we're going to have 3x plus 5 and 3x plus 1. Let's ask ourselves, does that seem to make sense? Does 5 times 1 multiply to 5? Yes. Does 3x times 3x multiply to 9x squared? Yes. You got your factors. We're good to go. Next one. Don't forget, multiply 3 times 8. We get 24. Technically negative 24. What multiplies to 24? We got to do 1 and 24. We got 2 and 12. We got 3 and 8. And we got 4 and 6. I recommend writing them down kind of in order. See how it goes? 1, 2, 3, 4. Makes it easier. Out of those, which ones will add to negative 2? That's going to be in the 4 and the 6. It's just going to be probably 4 minus 6 or 6 minus 4 or something like that. So I'm going to put in that. I'm going to put in my 4. I'm going to put in my 6. I'm going to put in my x. And here, because it needs to add to negative 2, it's going to be a negative 6 and a positive 4. Do not forget to divide by the 3, the number in front. We multiplied in the beginning. We divide at the end. This is the more typical version where they don't simplify. We got 6 divided by 3. That's going to be 2. Okay? And this 4 doesn't divide by 3 and it doesn't simplify, so you just put it in front. 3x plus 4. And then x minus 2, because 6 divided by 3 is 2. There is our final answer. And then our last problem, we have 9 times 6. 9 times 6 is 54. So what multiplies to 54 that adds to 15? But before we do that, always check to make sure it doesn't divide by something. Look, if you start with the 54, you're going to end up with a problem that's going to be a little bit funky, okay? Especially in the simplify step. This particular method, you need to check for your greatest common factor first. There are other methods. I have one that I call a tic-tac-toe board. Got a video on that. This is the method that I actually teach, but it is a little bit slower. Here, we can divide everything by 3. Let's do that first. We divide everything by 3. We get 3x squared minus 5x minus 2. There's a few benefits to dividing by 3. A, your numbers get smaller. B, your answer will be perfect. And that's the more important thing. We're multiplying this 3 times this 2 to get negative 6. What are some things that multiply to negative 6 that add to negative 5? We've already done that, actually. It was 1 and 6. It's also 2 and 3. But the 1 and 6 multiply to negative 6 and add to negative 5. So we're going to write that down now. We're going to have x minus 6 and x plus 1. The thing that most students forget to do is they forget to divide by the number that they multiplied by in the beginning, which was this 3. That 3 you have to divide both of these still individually by. So this is going to be 3 with an x minus 2. And this 3 goes in front of the x, so this would be 3x plus 1. You could also write it as, or you could write it as 3 with the 3x plus 1 and the x minus 2. Both of those are correct. Okay? Until next time, everybody, stay positive, and I will see y'all later. Bye.